Hello, welcome to my continuing series of Calculus BC lectures. This one is an example of using the Taylor theorem with remainder to calculate the largest error that can result from using a series. And so then we're going to use the Taylor series remainder theorem. So let's go ahead and start with the problem statement here. The Maclaurin series for ln of 1 plus x is x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4, etc. So the question is, what is the largest error which might result from using the first three terms of the series to approximate ln of 1 plus x for x between 0 and 1? Okay, so we're doing it for a whole range and not just one particular x value. So let's calculate the remainder term. Since we have the first three terms, we're going to need to go to the fourth term. That would be the remainder. And so r3 of x is equal to the fourth derivative at c times x to the fourth over 4 factorial, where c is between the center of the Taylor series and x. And so the Taylor series, this is a Maclaurin series, and it's centered at 0. So you see we needed the fourth derivative. So I've actually already taken the derivatives here. They're pretty simple to do. So here's the derivatives. F prime of x is 1 over 1 plus x. And then take the second derivative, that's like 1 plus x to the negative 1. So it's negative 1 times 1 plus x to the negative 2. And then multiply negative 2 times negative 1, you get 2 over 1 plus x cubed. And that's negative 3 times 2 is negative 6 over 1 plus x to the fourth. So that's our fourth derivative. So what we need to do then is go ahead and make sure I have the right color here picked. Try to write without any the correct color. So we're going to take this remainder, so r3 of x is going to be equal to the fourth derivative at c. So that's absolute value of negative 6 over 1 plus x to the fourth. Okay, and of course the absolute value here. We're interested in finding the maximum distance, the maximum error, and so we're not really interested in the sign of the error, whether it's above or below, but just how far off it might be. And then times x to the fourth over 4 factorial. And for ease of calculations, I'm going to write 4 factorial as 1 times 2 times 3 times 4. And you can see why that's nice, because then if we want to go over here and cancel things out, the 6 will cancel out the 2 times 3. And the absolute value is going to take care of the negative. So we can go back to simply the absolute value of the remainder is going to be equal to x to the fourth over 4 times 1 plus x to the fourth, or 1 plus c to the fourth. And notice I wrote that as x up there, so that was supposed to be c. So go up and fix that, please. And then what we're trying to do is we're trying to calculate the maximum remainder. So what we want to do is find out what values of x and what values of c maximize this remainder. So you can see if c, which has to be between 0 and x, so I suppose we should take care of x first. So the biggest value in our range, in our domain rather, that, so here's our domain, x between 0 and 1. So the biggest value of x to the fourth would be when we have x equal to 1. So then we're going to plug in 1 for x. And then the biggest value of this remainder when between 0 and x, again, where c is between the center of the Taylor series and x. So the center of the Taylor series is at 0, since this is a Maclaurin series. So we need to pick 0 to make the largest remainder for this. So that's 4 times 1 plus 0. And we end up getting 1/4. So the greatest distance, the greatest error, would be 1/4. And so that means our actual remainder is actually less than or equal to 1/4. So there we go. You can see that it's not that difficult of a problem if we just go ahead and just break it down into its pieces and take it nice and slow and make sure you're understanding what each piece means. So thanks for listening, and I'll be back to you with some new videos soon.